Lesson 10. Scalar products and angles between vectors. Scalar products of two vectors. The scalar or dot product of two vectors A and B is written as vector A dot vector B and is defined as vector A dot vector B equal to the product of the magnitude or modulus of the two vectors times cos theta, where theta is the angle between the vectors A and B. So you have vector A, vector B, theta, the angle between them. If vector A is equal to A1 vector I plus A2 vector J and vector B is equal to B1 vector I plus B2 vector J, then vector A dot vector B is equal to this. So when you expand, you have A1 vector I times B1 vector I. You have A1 B1 vector I dot vector I. You take the first one times the second, you have this result. Then the second one here times the first, you have this result. The second times the second, you have this result. Recall that vectors I and J are mutually perpendicular unit vectors. If two vectors are in the same direction, the angle between them is 0. And if in different directions and perpendicular to one another, the angle between them is 90 degrees. This will help us to simplify vector I dot vector I. Both are in the same direction. Hence, the angle between them is 0. So, vector I dot vector I is simply 1 times 1. They are unit vector in the same direction. For that reason, the angle between them is 0 degrees. 1 times 1 is 1, cos 0 degrees is 1, so you have 1. Then vector I dot vector J, they are in different directions. The angle between them is 90 degrees. When you evaluate this, you have 0 because cos 90 degrees is 0. Times 1 times 1, you have 0. Then you take vector J dot I, different directions, you also have 0. Then vector J dot vector J, they are in the same direction. The angle between them is 0. When you simplify, you have 1. Hence, vector A dot vector B is equal to A1 B1 plus A2 B2. If you go back to the previous expression where you have A1 B1 vector I dot vector I, so you replace vector I dot vector I with 1, then vector I dot vector J with 0. That term becomes 0. After doing that, you have this as the scalar or dot product of two vectors. if vectors A and B are three-dimensional, that is, if vector A is equal to A1 vector I plus A2 vector J plus A3 vector K, and vector B is equal to this. When you carry out the simplification for vector A dot vector B, you have this result as the scalar or dot product. Properties of scalar or dot products. Number one, commutativity. If you have vector A dot vector B is equal to vector B dot vector A, scalar multiplication, you have it in this form. You have distributive property, you have it in this form. Now, the dot product of a vector by itself is equal to the square of the magnitude of the vector. Given that, that is the fifth property, vector A dot vector B is equal to 0. If alpha is the angle between vector A and vector B, then the product of the magnitude of the two vectors times cos alpha is equal to 0. It follows that either the magnitude of A is equal to 0 or magnitude of B is equal to 0 or both. That is, cos alpha is equal to 0. If vector A dot vector A is equal to 0, then vector A itself is equal to 0. The dot product gives us a very nice method for determining if two vectors are perpendicular or orthogonal, and it gives another method for determining when two vectors are parallel. Note number one, two vectors A and B are perpendicular or orthogonal if their dot product is equal to 0. In other words, vectors A and B are orthogonal if the angle between them is 90 degrees. Note 2. Two vectors A and B are parallel if their dot product is equal to the product of their magnitude. In other words, vectors A and B are parallel if the angle between them is 0. You have to note these 2 points. Next is angles between 2 vectors. From the definition of the dot product of the vectors A and B, the angle theta, as in figure 22. This figure is the angle between the 2 vectors, and it is defined as cos theta equal to the dot product over the product of the magnitudes of the 2 vectors. Examples 24. Find the scalar product of the following pairs of vectors. A, you have vector A and vector B. B part of it, you have vector C and vector D. Solution. The dot or scalar product of vector A and B is equal to the first component of vector A times the first component of vector B. You have it in this form, plus the second component of vector A times the second component of vector B. You have it in this form. So you have the minus outside. Root 2 times root 2 is root 4, which is equal to 2, plus 3, the product from here. And when you add, you have 1. B, the scalar product between vectors C and D is equal to this. First component times first component, that is 7, 4 in this form, plus the product of the second plus the product of the third. When you multiply, you have this result. After addition, you have 26 as the scalar product or dot product. Example 25, find the angles between the following pairs of vectors. A part of the problem, B part of the problem. Solution. Let's give the vectors name. So let vector A equal to the first vector and vector B. Let theta 1 be the angle between vectors A and B. Therefore, cos theta 1 is given in this form. We need the magnitude of both vectors and their dot product. So magnitude of vector A is equal to square root of 3 square, the first component, plus minus 1 square, the second component. You have it in this form. For vector B, the same thing, and you have root 29. Next is to get the dot product, which is this, and you have 13. Therefore, cos theta 1 is equal to 13 over root 10 times root 29. That is 13 over root 290. To get theta 1, you take the inverse of cosine of both sides, and you have it in this form. B part of the question, let C be the first vector and D the second vector. Let theta 2 be the angle between the vectors C and D. Therefore, cos theta 2 is equal to this. You compute the magnitude of vector C. You have root 70. Magnitude of vector D, you have root 45. The dot product of the two vectors, and you have minus 32. Therefore, cos theta 2 is equal to minus 32 over the product of the magnitudes of the two vectors. You have it in this form. To get theta 2, take the inverse of cosine of both sides, and you have it in this form. End of lesson 10. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared.